Good evening. This is Professor Lauen. This is my daughter, Tessa. She is going to be my co-star today. Um, Many of you are worried because you had binary outcome variables for your first memos. And now some of you are searching for continuous variables. If you wrote a perfectly good memo for your first assignment, you shouldn't throw it out just because you're afraid to do the linear probability model. The linear probability model is your friend. It's the model that you can use on a binary outcome. And it works just fine, right, Tessa? The linear probability model works just fine. Okay. Yeah, that's okay. Well, don't worry about that. Okay, so we're going to do a little analysis in NLSY. We're going to create a variable called divorced out of the marital variable. And then we're going to create a variable called dropout out of the highest grade ever attended variable. And then we're going to use a control variable family inc. So divorced is the outcome, that's binary. Dropout is the main policy variable, that's binary. And family income is continuous. So we have two right-hand side variables, one continuous, one binary, and then we have a binary outcome, and we're going to estimate this with ordinary least squares regression with Stata's regress command, okay, right here. And then we're going to compare it with results that we'd get from the logit model, and then we're going to interpret all the results, okay? So I'm just going to highlight all this and do it. Voila. Run it. Voila. Easy. Very good. Okay, and we're going to look at all the results now. Okay, so we're going to, all the recoding stuff is boring, right? Recoding is boring, isn't it, Tessa?
I don't know what that means, but it sounds pretty boring.
Sounds pretty boring. Indeed it is. But it's very important. If you do it wrong, you get junk. Garbage in, garbage out.
Really? If you do it wrong, you get a piece of
you get actual garbage. That's right. Okay, so what we have here is a regression. So we've got the outcome here, divorced, and the explanatory variable dropout. Okay, the coefficient on dropout is right here. Okay, so the way we interpret this, hush, co-star, be quiet. Okay, so the way we interpret this is that the effect of going from 0 to 1 on dropout is 0.02 on divorced. What does that really mean? That means that increasing, that going from not being a dropout to being a dropout increases the probability of becoming divorced by 0.02. The baseline probability is 0.038, which is about 0.04. So a high school graduate has a probability of getting married and then being divorced of 0.04 or 4%, and being a dropout increases that to about 6%. Okay, so we can use the predict command right after the estimation to predict a variable called PP1, that's the predicted probabilities. Okay, and then we can do a logit model. I know many of you are afraid of the logit model. And so we'll do that, and we run that, and we get a logit coefficient out of that, and then we predict after that a different variable called pp2. Okay, and then we create a table. Can we just use the table command? Okay, no more of that. Thank you very much. Okay, is this too boring for you?
Yeah.
What would make it more interesting?
Rolling in the deep.
Rolling in the deep? What's that?
It's by Adele.
Adele. Oh, Tessa's favorite song, Rolling in the Deep. So we're going to have a little soundtrack here. Okay.
That was my second favorite. Whatever. Still counts.
Okay, we're going to get a soundtrack. Cue the music. Cue music. Oh, I don't think that's going to work. We can't listen to Adele. Sorry, honey. Oh, there it is. There it is. Wait. Oh, there it is. There's Adele. Okay, so hopefully this will be more interesting with Adele. Is it more interesting? It's more interesting. Okay, so you can see that the predicted probabilities are exactly the same from PP1, which is estimated from the linear probability model, and PP2, which is estimated from the logit model. Okay, now we're going to include a confounder, income, which is measured in thousands, And I do my little correlation matrix here, and I see that divorced is not very well correlated with income, so it's probably not a very good confounder. Income is pretty correlated with dropping out in the expected direction. So I predict that when I put it in to the model with divorced and dropout, it's probably not going to change the coefficient on dropout very much. So before, it was in the linear probability model was 0.021. All right. When I put it in when I put income, the confounder in, it goes to 0.020. It changes a little bit. Where did my co-star go? She's dancing. Sure, you can go right ahead, honey. Okay, so it goes down a little bit because the product of these two correlations is positive. So the other thing is estimated with a little upward bias. But the way we interpret this is basically the same with the dropout. You know, being a dropout increases the probability by 0.02 points. Income has a small negative association with being divorced, but it's not statistically significant at the 0.05 level. So again, it's very easy to interpret the linear probability model. The linear probability model is your friend, and I hope this was very successful. Oh, thank you for the water. Good night. Enjoy. I look forward to reading your memos. Bye-bye.